Hello everyone. Today in this video we are going to discuss beta function along with beta function and their properties of the beta function. So first of all, beta function. What is beta function? So just I write the definition here and then I'll explain the terms. Beta mn, the definite integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx is called beta mn. Or beta function, and it is denoted by Bmn, means it is beta, Greek letter beta mn. That is, beta mn is equal to integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. M, n are positive numbers. They are positive, more than 0. Both are positive. So this integral is known as beta function. Now, in this integral, we find some terms. Limits. Limits are generally 0 and 1. Limits are 0 and 1. And integrand is the product of x raised to m minus 1 and 1 minus x raised to n minus 1. Both are algebraic functions. Both are algebraic. And if we ignore the power, just ignore the power, the integrand will be x and 1 minus x. If the integrand is x and 1 minus x and upper limit is 1, lower limit is 0, the integral belongs to beta function. This is known as beta function. Consider, now let us see this one. If we ignore the power, the two factors multiplying are x and 1 minus x. Like this. So I am giving you the clue or to decide which type of integral is called beta integral. X and 1 minus x. Now ignore the powers. Just ignore the power initially. X and 1 minus x are the two functions, multiplying functions. What is their addition? Addition of x and 1 minus x is 1, and that is upper limit. So that is the criteria to decide whether the given integral is the beta integral. Both the functions are algebraic, and if we ignore the powers, then sum of the two functions x and 1 minus x is always equal to 1, and that is the upper limit, provided the lower limit is 0. In that case, the lower limit is generally 0. So this kind of integral is known as beta integral. That is beta function. Beta integral, beta function are also called beta integral. So very useful integral, or this integral is generally useful, or it is one of the method of integration, we can say. If m and n are the large quantities, then we can introduce a symbol for this integral, and by that symbol you can find the value of the integral easily. We will see while discussing the examples or while solving the example, you will get how to decide m and n and find the value of the beta function. So this is known as beta function. Now, this integral, let us see. So whenever the problem is given, you try to find out lower limit of the integral as 0, upper limit as 1. Integrand is the product of two algebraic functions, x raised to m minus 1 and 1 minus x raised to n minus 1. And when the powers are ignored, sum of the two is always 0. Let us see another, just in this example, 0 to n x cube into n minus x raised to 4 dx. Suppose you are asked to solve this example, isn't it? Is the lower limit 0? Lower limit is 0. And if the upper limit is the sum of the two functions, irrespective of the powers, isn't it? Ignore the powers, x and n minus x. What is the sum? Sum is n. And is it the upper limit? It is the upper limit. And therefore, this integral can be easily solved by beta function. Isn't it? So that is the example of the beta function. Now this is the definition of the beta function. So beta function is defined as, just I define here. M and N are the numbers, positive numbers. So beta Mn is integral 0 to 1 x raised to m minus 1 and 1 minus x raised to n minus 1 dx. So that is the definition of the beta function. Limits are 0 and 1. Integrand is the product of x and 1 minus x. And that function is known as beta function. Now to write the numbers of this notation or the function, add 1 to the power of this m minus 1 and add 1 in another power n minus 1. Adding 1 in each power, you will get some numbers and write that numbers in this symbol. Now let us see properties. Beta function. The first one, beta Mn is symmetrical. That is, m and n are interchangeable. Beta Mn is always equal to beta Nn. That is the first property. M and n are interchangeable. Therefore, the function is called beta Mn is symmetrical function. The second one, beta Mn as a trigonometric function like this 0 to pi by 2 twice 0 to pi by 2 sine theta raised to 2m minus 1 into cos theta raised to 2m minus 1 d theta. Theta is a variable. Here x is a variable, theta is a variable. And you know one of the property of the definite integral, the value of the integral depends on function, not on the variable. The variable of integration is immaterial. The value of the integral depends on the function and the limits of the integral. So here tx is a variable, here theta is a variable. Third one, it is the application of this property. Integral 0 to pi by 2. Limits are 0 and pi by 2. If the integrand is the product of trigonometric functions sine and cosine, limits will be 0 to pi by 2. Isn't it? But remember, this is a basic definition. So 0 to pi by 2 sine theta raised to p into cos theta raised to q. So this formula, Gaussian is a formula, is developed from this property by assuming 2m minus 1 is equal to p and 2 n minus 1 as q. Assume 2m minus 1 as p and 2n minus 1 as q, isn't it? Then it becomes 1 by 2 beta p plus 1 by 2 comma q plus 1 by 2. So that is the property. Or you may say this is a formula, and generally use this formula when p and q are the fractional numbers or smaller integers 2, 3, 4, etc. Isn't it? So this is the useful formula in beta function. The fourth one is relation between beta and gamma function. So very important formula. Very important property. Means by this property, beta function is reduced to gamma function, and then we can find the value of the gamma function or value of the integral. Beta Mn is equal to, it is gamma of the first number m multiplied by gamma of second number n divided by gamma of sum. Gamma of the first element, first number, gamma of the second number divided by sum of the, or gamma of the sum, and that is called relation between beta and gamma function. You can say this is the relation and this is the property as well as formula to find out the value of the integral. Okay. Now the fifth one is another useful property. Fifth one, that is also called duplication formula, and it is gamma m plus 1 by 2 is root pi upon 2 raised to 2m minus 1 2 to the power 2m minus 1 gamma 2m. Again another useful and very important property from beta function, duplication formula. Now here it is in gamma only. Gamma m plus 1 by 2 is root pi upon 2 raised to 2m minus 1 gamma 2m. So these are the useful properties of beta function, isn't it? So using these properties you can just solve, no need to prove all these properties, isn't it? We just use them to solve the problems, numerical problems. Okay, so this is all about definition of beta function and also some properties. And one more property is there, that is also a definition, sixth one, and that is integral 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n is beta m. So sixth property is nothing but second definition of beta function. This is the first definition and this is second definition. If we compare, just see this one, if the limits are 0 and infinity, suppose limits are 0 and infinity, you ignore the powers, then you will get x upon 1 plus x. So integrand is the division of x and 1 plus x, x 1 plus x, and here it is multiplication of x and 1 minus x. Limits are 0 and 1, try to find out x and 1 minus x. Limits are 0 to infinity, again the functions are algebraic, both are algebraic functions, there is a division. If the powers are ignored, then it is x upon 1 plus x. Division of x and 1 plus x, and here it is multiplication of x and 1 minus x. So all these are the very useful properties from beta function. Is it okay? Now just note down these properties, and using these properties and this definition we will see some useful examples from beta function. For example, let us see this example. Very useful example. Integral, prove that integral minus 1 to 1 plus x raised to m into 1 minus x raised to n dx is equal to 2 raised to m plus n plus 1 beta m plus 1 n plus 1. That is the result in terms of beta. So let us see again here. Let I equals integral minus 1 to 1 plus x raised to m dx. This is the integral, and the integral is to be solved by beta function. Why only by beta function? Because let us see here, limits are minus 1 to 1. Limits are not 0 to 1 like the definition of the beta function. But remember here, in the definition of beta function, 0 to 1 x raised to m and 1 minus x raised to n minus 1 dx. This is the definition. One of the function will be 0 for lower limit and another function is 0 for upper limit. See, this factor is, or this function is 0 when x is equal to 0 and this is 0 when x is equal to 1. Isn't it? Both are algebraic. Both are algebraic and they are 0 for lower limit as well as upper limit. So this is the general criteria to decide whether the function belongs to beta function. See here, 1 plus x algebraic, 1 minus x also algebraic. Limits are minus 1 to 1. Ignore the powers and see this 1 plus x and 1 minus x. Just just try to understand how to decide the substitution for such examples. Okay. Now, 1 plus x and 1 minus x are the two functions multiplying. These two functions are multiplying. Okay. Now, which one is 0 for lower limit? And the another one must be 0 for upper limit. Now, 1 plus x is 0 for lower limit. See this. What is 1 minus 1? 1 minus 1 is 0. So, one of the function is 0 for the lower limit, another function will be 0 for the upper limit. Here also, 1 plus x is 0 for lower limit and 1 minus x is 0 for upper limit. Means you may try this example by beta function. Isn't it? Now, let us see the substitution. So, which function is 0 for lower limit? 1 plus x. 1 plus x is 0 for lower limit. Make the substitution for this function. Let us assume the expression which is 0 for lower limit. Ignore the powers, irrespective of the powers. 1 plus x. 1 plus x is 0 for which limit? Lower. And let us assume 1 plus x is equal to t multiplied by difference of upper and lower limit 1 minus minus 1. Take the difference of these two. Just upper limit 1 minus minus 1 and you multiply by t is a new variable. So always remember this is a substitution when the lower limit is not equal to 0. And if the lower limit is 0, then using this 1 minus x you can decide the substitution. So here 1 plus x is 0 for the lower limit is not equal to 0. So let us consider 1 plus x is equal to difference of the two limits, upper limit minus lower limit. Generally upper limit is always more than lower limit. So upper limit minus lower limit multiplied by new variable t. T is the new variable. Therefore, by this substitution, you will get the value of x in terms of t. 1 plus x is 2t. X will be 2t minus 1. And that is substitution. So consider x is equal to 2t minus 1. Okay. Then after that, find all the factors, all the functions in terms of t, new variable t. So we are going to change the variable x to variable t. So express every factor in terms of t. So dx from x, differential of x is given as 2 into differential of t dt minus differential of 1 is 0. So dx will be 2 dt. Got the value of dx. This is the value of dx. Then 1 plus x. Already we have the value of 1 plus x in the substitution. This is 1 plus x. 2t. Then find the value of 1 minus x. 1 minus x is equal to 1 minus the value of x is 2t minus 1 is equal to 1 minus 2t plus 1, that is 2 minus 2t. 2 common, 1 minus t. So 1 plus 1 minus x is 2 into 1 minus t. That is value of 1 minus x. So by this way, express x and every factor in terms of any variable. And after that, the main thing is to change the limits. In a definite integral, when we make the substitution, always change the limits of integration. Now, when x is equal to minus 1, lower limit, x is equal to minus 1. X is equal to minus 1. So, in this case, put the value of x. You will get 1 plus minus 1 is equal to 2t, or 0 is equal to 2t implies t is equal to 0. So, the lower limit of t is 0. So, that is the lower limit of t. Okay. Now, then upper limit. In the same function, using this function, we will find the limit. When x is equal to 1, upper limit is 1. We are going to change, or we are going to find the limits of new variable t by this limits of x variable. So when x is equal to 1, 2t is 1 plus 1, 2t is 2, t is 1. That is value of t. So that is the value of t. So these are the limits of integral. So after that, we put all the values in the integral I and simplify. Now, let us see the integral. I is equal to I equals to. So here I write the value of I. What is the lower limit of t? 0. Upper limit of t is 1. So what is 1 plus x? 1 plus x is 2t raised to m. Value of 1 minus x. 1 minus x is 2 into 1 minus t. Power is n. And dx is 2 dt. 2 dt. That is value of dx. So that is the integral in terms of new variable t. The new variable is t. Okay. Now is equal to, write all the multiples of all the factors. This is a single term and two functions are multiplying. Write their constant multiples outside the integral. So in the first function, in the first factor, 2t, 2 is the multiple with power m, 2 raised to m. Then 2 is the multiple in the second factor, power is n, so write outside. And then multiple of dt is 2, write 2 also outside. Integral 0 to 1, limits are 0 and 1, t raised to m multiplied by 1 minus t raised to n dt. And that is the integral now. So that is the final integral. So after that, we just introduce the symbol for the integral. We will get the answer. Isn't it? See here, this is 0 for lower limit and this is 0 for upper limit. Limits are 0 and 1 according to the definition of the beta function. Limits are 0 to 1. Limits are 0 to 1. T is 0 for lower limit, 1 minus t is 0 for upper limit. So it is a beta function. And to write this in beta function, the multiple is 2 raised to m plus n plus 1. This is the multiple. 2 raised to m into 2 raised to n into 2. And just 2 raised to m plus n plus 1. And now, as it is a beta function, beta, add 1 in each power and write in the beta notation. Add 1 in the first power m, you will get m plus 1. Then 1 in the second power, you will get n plus 1. And that is the result. So that we want to show that. And by this way, you can simplify. So that is the method to solve the example on beta function. Let us see another example. Prove that, second example, integral 0 to infinity x raised to m minus 1 upon a plus b x raised to m plus n dx is beta mn upon a raised to n b raised to n. So that is the consideration. So now to prove this integral, let us see the limits of integral 0 and infinity. When the limits are 0 and infinity, denominator may be in the form of or must be in the form of a or some constant 1 plus t. So this expression is very important. Our expression of this type is important in this integral. And here see here, limits are 0 and infinity and there is the expression of a plus bx. Ignore the powers. A plus bx is identical with 1 plus t. It is identical. So can be solved by beta function. Like when the limits are 0 and 1, integrand must contain 1 minus t, one of the factor. Isn't it? And when the limits are 0 and infinity, integrand must contain 1 upon 1 plus t. So we just try to compare the integrand or the factors of the integrand with this factor to decide the substitution. That is integral 0 to infinity t raised to m minus 1 upon 1 plus t raised to m plus n dt is beta mn. Second definition. So for this example, we are going to use this definition and you just compare the factor. So whenever limits are 0 and infinity, denominator must be 1 plus t. And when the limits are 0 and 1, one of the factor is 1 minus t at numerator. Now, just see this one, a plus b is identical with 1 plus t. So if we call this as I equals to, see substitution for this integral now, very simple substitution, x raised to m minus 1 upon a plus bx raised to m plus n dx. That is the integral. Now, for 0 to infinity, a plus bx is the main factor or the important factor. So let us make the substitution for x in such a way that this a plus bx changes to 1 plus t. We have to change a plus bx to 1 plus t. So for that, let bx, this is bx, variable term, is equal to constant term of that factor into new variable t. If we substitute bx is equal to at, then it will be a plus at. A will be common, we will get 1 plus t and we require 1 plus t. Ignore the powers. Ignore the powers and decide the substitution. Isn't it? Now, as bx is equal to at, x will be a by b into t. Find the value of the variable. After substitution, decide the variable so that you can find differential of this x as dx, a by b, and what is the differential of t? Dt. So we got this value. That is value of dx. Okay. Then after that, a plus bx. So here I write a plus bx. A plus bx is equal to a plus at is equal to a common 1 plus t. That is value of a plus bx. So that is the value of this a plus bx. A multiplied by 1 plus t. And now put the value in the integral. So integral I becomes, put the above values in I. Also change the limits. So what are the limits? When x is equal to 0, from this substitution, when x is 0, x is equal to 0, t will be 0. And when x is equal to infinity, x is infinity, infinity equals to a by b, so t will be infinity. So limits are same limits, but we have to write the limits. So I will be integral 0 to infinity x. Now put the value of x. X is a by b into t. Raised to m minus 1 into dx a by b dt divided by a plus bx. A plus bx is a into 1 plus t. A into 1 plus t raised to power m plus n. So these are the changes. And now just simplify. Now write all the multiple constants at numerator as well as denominator outside the integral. So here, see, this is the multiple of this factor, function a by b with power m minus 1. So write here a by b raised to power m minus 1. Then another factor a by b, write outside. From denominator, a is the multiple constant with power m plus n, a raised to m plus n. Integral 0 to infinity t raised to m minus 1 dt divided by 1 plus t only. 1 plus 2 is left only, t left, it is m plus n. That is a definite integral. Now this is equal to, see again here, a by b, same denominator, so add the powers. A by b raised to m minus 1, a by b raised to 1 means it is a by b raised to m only, divided by a raised to m, separate this one, into a raised to m. And what is this? Definition of, second definition of beta. So it is beta m. It is beta m is equal to, now a raised to m is a numerator and this b is the denominator of this numerator. It becomes again, or it will be a denominator, b raised to m into a raised to m. Shift this one to the denominator, a raised to m into a raised to m, beta m. Then cancel this a raised to m with this a raised to m. You will get 1 upon b raised to m into a raised to m beta m. And that is answer. So that we want to show it. So this is the way. So generally from the integral you decide the substitution. Isn't it? So there are number of integrals and number of substitutions. And using that substitution, you just remember the criteria. Limits must be 0 and infinity, 0 and 1. Then one of the integrand, one of the factor in the integrand is 1 minus t, which is 0 for upper limit. See this one. This one is 0 for upper limit. Isn't it? And this one also 0 for the upper limit. What is t? Infinity. Infinity plus 1 is infinity. And 1 upon infinity is 0. This is 0 for upper limit. This one also 0 for the upper limit. So by this concept, by this idea, isn't it? You try to solve more examples on beta function. So this is the way to define beta function and to solve the examples on beta function. In the next video, we will see some more examples on beta function as well as gamma function, both the integrals. So is it clear to all of you? Okay. Now this is my second video on beta function. Then subscribe, share and like this so that you will get my new videos as early as possible.